Hi, here it is a new session about creating the pipeline from the image. In this session, we will write the pipeline code needed to execute the unit and integration tests. Since these tests are running in a virtual machine in Docker containers, I have started the test machine in VirtualBox and I have exposed the environment. We will need the Jenkins agent UT and Jenkins agent IT images, but before that we need to do some configuration in Jenkins master. So now we have to enter in Jenkins, and we have to indicate to Jenkins how to communicate with our test machine. For this we will use the Docker plugin, so you have to install this first. And now from manage Jenkins we go to configure system, and here in the cloud session we will add a new Docker. This is basically a new Docker machine. We will provide a name. In this case, let's call it test machine, and we need a Docker URL. For this we can basically the Docker URL is this one, but in case you don't know it, we can use this command to find out the Docker machine IP. So we need this IP, and we will type it here. And the port also. Now we can try to test the connection. As you see, there is an error. This is normal because Jenkins cannot connect to the Docker machine because it doesn't have the credentials. The credentials that we need to provide are actually the Docker certificates, and for this we will create a new credentials in Jenkins, and this time we will choose Docker certificates directory. Further, we need to specify the path. Basically, this is the path where the Docker certificates are. In this case, in this specific case with the VirtualBox and Windows 7 and so on, the certificates are available in the users folder, in the Docker folder, in here. So you can see that for each of our machines there is a folder. So what we need is actually this path, and this path we will simply paste it in Docker, and we will click add. Okay, we also have to choose the credentials, and we can test again. As you can see, this time Jenkins reports that he found the machine, and the machine runs this version of Docker. We will copy this and paste it here in the Docker API version. Okay, so now Jenkins can communicate with our Docker machine with the test machine. Okay. What we have to do next is to specify several Docker templates. Basically, this is the list of images that runs on the test machine. So we need the Jenkins agent UT first. So this is our image that will fire up a container that we can use to run the unit tests. So I will say add Docker template. Now we need to configure our images. The first image that we configure is the Jenkins agent UT, the unit testing image. We specify the name of it here. We will associate a label to this image. This way we can indicate that this container should be used for a specific task. So we don't allow to use this node as much as possible, and only when we indicate it. And we choose Docker One's retention strategy, which means that the Jenkins will start and destroy the container when this becomes useless. We can also choose keep this agent online as much as possible. In this case, Jenkins will not destroy the container, and it will try to reuse it when a new build is triggered. The number of executors is correctly set to 1 in our case. Now we have to focus on the launch method. We will use Docker SSH computer launcher, and for this we have to specify some credentials. If you remember, when we have created the Docker image, we have set a user Jenkins to the image, so this user is available inside the test machine. Now we have to tell the Jenkins master about these credentials. So we will choose Jenkins, and we will say username and password. The username is Jenkins. The password is also Jenkins, and we will say here agent as an ID. Okay, I will choose these credentials. So now the Jenkins master can communicate with this agent, and everything else remains as default. Of course, you can use this help from here if you want to fine-tune more details. Okay, now I will configure the next image, Jenkins agent IT from integration testing. So I will add a new Docker template. I will follow the same model. Okay, I will specify a label. Basically, there are the same settings as earlier, only the image is different. Okay, so I have set up the Docker host. I have set up 2 Docker images, and now we can click save, and we are ready to continue with our pipeline. Okay, so now let's get back to our pipeline. So this is the code of our pipeline so far. I will add here the code needed to run the unit testing. So this is the code. What is happening here? First, we set up the Maven and the Java home variables. As you can see, this time the path are Linux specific path, since we are inside the test machine. And we have a stage, I call it run UT. So first we have to unstash the source code. So our project source code now is copied inside the container, and we invoke Maven with clean and test goal. Okay, so now this is basically the code for running the unit testing. We can commit. And now we can try a build. Actually, before we try to start up a build, let's notice the fact that so far there is no container running, and now let's see if our job our build should start a container on test machine. Okay, so we need to have a little patience. So the project version was changed. Okay, okay, the files, the source code, the files were stashed. So now we can see here the fact that Jenkins has fired up a new container using the Jenkins agent UT image, and now is unstashing the project source code, and it runs the Maven clean test command. Okay, now I will speed up the video a little bit because it will take some time until all the artifacts are downloaded. Okay, so as you can see, the pipeline ended, the tests were executed. There are just some dummy tests, there is nothing important. You can I will show you quickly, you can find them here. So we have some unit tests. Okay, so nothing fancy. They successfully passed. We have 2 tests. So test run 2, no failures, no errors, no skipped, and the build was a success. And now if we check out the container, we can see that the container was destroyed by Jenkins. Okay, now let's focus on integration tests. Okay, so the code for integration tests is this one. Again, we set the Maven in the Java home variables, we unstash the source code, only that this time we also need to fire up Postgres, because our integration tools will need to connect to this database. And finally we run the integration test. We invoke Maven with clean verify goals, and we specify the fact that we want to skip the unit tests. So since the unit tests are running in this container, the integration tests are running into another container, and of course we don't want to execute the unit tests again. Okay, let's commit this. Okay, so at this moment there is no container running. We are waiting for the unit testing container. Here it is. I will speed up the video here. Okay, so the unit test was successfully finished. Now the integration test should come up. As you can see, the Jenkins agent, so this container was destroyed, while another container using Jenkins agent IT was started. Okay, so now we know that the container is running. Let's see the output. Okay, now we start Postgre is done. Okay, and now we run the test again. There is a downloading session, so I will speed up again. Okay, so the integration test ended. They were successfully run. There are 4 tests. I will show you immediately. Here it is. Basically, there is just some dummy tests. We are mocking some controllers, and we execute a test that is checking the connection to Postgre database, to default database and to the database that we have configured in our Docker image. So since this test was successfully passed, it means that our application has successfully connected to Postgres inside the container. There is no container left, so let's focus now on another aspect. So our pipeline design shows that the unit test and integration test should run in the same time, but so far our integration tests run after the unit test. Normally we can shape this behavior, because when we run the integration test, we skip the unit test, while the unit tests are executing in the Maven test phase. They don't run the integration test. So in order to obtain this behavior and run the unit and integration tests in the same time, we can use a command from Jenkins pipeline, the parallel command. Let's see how we can do this. So this is our integration test and this is our unit test, and I will replace this code with this one. Now, as you can see, I have added the parallel command. Now I configured the pipeline to run these 2 nodes in the same time, and I want to fail fast, because if the unit test will fail, there is no need to continue running the integration tests, which normally takes longer. Okay, let's commit and let's see how it works. Okay, this time we should see output in the same time from two containers. As you can see here, the pipeline says that it's reporting the unit test branch and the integration test branch. I'm referring to the pipeline branch, not to the GitHub branches, right? So now let's see. There are actually two containers. So now unit test runs in the first container and the integration tests run in the second container. Okay, most probably this will take some time, so let's wait a minute until. Okay, so we can see the Postgres starting, and now I will speed up the video here. Okay, the pipeline is done, and now we can see that there is no container, so the test has successfully passed, and they have been executed in parallel. Okay, so far so good. Now if we look to our pipeline design, we can see that beside the unit tests and integration tests, we want to run the JCoco for code coverage. In order to accomplish this, we need to install in Jenkins the JCoco plugin. So I will suppose that you can do this very easy. And now we need some code in our pipeline. Now the code that we have to add to our pipeline is this one. We add a piece of code in the unit test section, and another piece of code in the integration test section. So after the unit test we run JCoco, and after the integration test also. In both cases we get the JCoco report via the JCoco publisher, and at the end we stash the JCoco output, because in one of the next sessions we will unstash these files and import them in SonarQube. Now the JCoco publisher is based on the JCoco plugin, and will output an report in the Jenkins master, as you will see soon. So now we can commit and try to build a pipeline. Let's see the output. Okay, so now I will speed up the video until the pipeline ends. Okay, so the pipeline is done. I resume the video from here, and now as we can see, we have the overall coverage of integration test. Actually, this is the entire coverage. Let's see. Here we have the coverage for the unit test, and here we have the entire coverage. Now let's see the output from Jenkins. So this is the report. It looks like there is an issue in Jenkins, because the report appears twice, but is not such a big issue. So this is the overall coverage summary that puts together the result of running JCoco after the unit tests and after the integration tests. Now it's important to notice the fact that JCoco is a fast tool because JCoco doesn't need to instrument jars as Cobertura does. You can also use Cobertura or Clover or any other code coverage tool, but JCoco run really fast, and it has the advantage that it can be run after the unit test and integration tests without recompiling or instrumented jars. So we can choose from multiple code coverage tools, but an important aspect is the reason for placing such a tool inside the pipeline. Mainly, a code coverage tool should be capable to cause the pipeline failure. If we want to use a code coverage tool only for reporting, then we can take out the code coverage tool from the pipeline, and we can execute it as a separate job. For example, in our build, the unit test coverage has a 41 for instruction. Now we can decide that if the instruction is not over 50, then the pipeline should fail. Okay, so I resumed the video from here. As you can see, the pipeline is done and it failed. Now we can easily see the reason of failure by inspecting the coverage report. As you can see here, the instruction coverage didn't pass the thresholds, that the 50 thresholds that we have set it, so the pipeline failed. Now, following the same technique, we can set thresholds for branch complexity and so on. The easiest way to do this is to follow the pipeline syntax. Simply select step, record JCoco coverage report, and this is the section of the thresholds. You have to tick this checkbox in order to instruct the pipeline to fail if the thresholds are not met, and finally click generate pipeline script, and this is the script that you can take and copy and use in your pipeline. Okay, for now I will remove the thresholds from here, since we don't want to have a failed build further, and we can go to the next task. Now the next task that we want to accomplish is to obtain the JUnit report. This can be easily accomplished by using the JUnit plugin. So you have to install this in Jenkins, and the code that we need to add in the pipeline is this one. So we add in the unit test section, we add the surefire reports, while in the integration section we add the fail-safe reports. Okay, let's see how it works. I will speed up the video now. Now the pipeline ended, and we can try to see if the unit test report is available. Okay, so as you can see here, we have the test results trend, and in here we have the test result with more details that you can explore. Okay, since the JUnit report cannot cause the pipeline failure, it can be a good technique to execute it outside the pipeline. Also, if you need a more advanced, a more detailed report, you can choose to publish the HTML reports. In order to do this, you can use the pipeline syntax, and you need to execute the Maven site goal. Okay, these reports are not available in this video. Okay, so that's it for this session. I hope I will see you in the next session when we will run several static code analysis like find bags, check style, and PMD. See you soon.